Happy Friday, everybody. Before we get started with the glorious Excel activities that I have planned, I do want to make a few announcements. So first of all, I have updated extra credit activities. For those of you who attended extra credit and were signed in, then you should have for Meet the Firms. If you wouldn't attended Meet the Firms and were signed in, then you should have a 5 next to your extra credit score. If you did attend Meet the Firms and do not have a score next to your name, please let me know. I'm operating off of the sign-in sheet that I was provided, and it is not infallible. I tried to match both first name and last name, and if there were any matches, then I tried to check in further. Certainly possible I missed something. So please just reach out. Related to that point, there are a few people who did not attend, which in AIS, that's expected because not every single person in the room is going to be an accounting major. So if you did not attend, but are still wanting to get extra credit, please remember that Thursday, September 26th, a little bit less than 2 weeks away. So yeah, so it'll be on Thursday, 2 weeks from now. That's going to be our career expo, and you can attend that and get your extra credit. If you attend Meet the Firms, you don't get to double dip. You don't get to attend both and say, I get more extra credit, right, Dr. Barnes? I'm going to shake my head and say, sadly, I just said, no, it's a one-time event. But I encourage you to attend if you are interested in attending. That's still an option for you. Also, at 4 weeks, I kind of give a state of the course speech and say where everybody's standing at. This has varied in previous years. Sometimes I have to say, you guys got to try really, really hard. You're just not quite getting it, or you're just not putting in as much effort as I'd like in. I have no complaints so far. Everybody's done generally well in the course. There have been hiccups here and there, but they've been very minor. So please keep up the good work. We're a quarter of the way there after today, a little bit over a quarter of the way, but I'm kind of rounding. If we maintain this performance, then I think everybody will be pleased with their grade at the end of the semester. All right, today, Excel Friday number 3. One of my functions or my functions that I embed fairly frequently. We're going to talk a lot about if statements as well as some other general statements. My comment about if statements is you should probably know that they're exceedingly useful right now, but the real use of if statements is whether or not you can utilize them with other functions as well, whether you can utilize them to create a formula that's a lot more powerful than standalone. We're going to do some very basic ones today. I will say that I constantly surprise myself at how many different ways you can utilize if functions in a spreadsheet. I'm working on a research project right now where I was trying to set up a conditional formatting, but I wanted all conditional formatting to click at once. So there was like about 20 inputs that had to all be correct. And if that was the case, conditional formatting clicked on and everything turned green when all 20 inputs were incorrect. And I was like, I don't understand how this will work. And the answer was that I just basically had to set up a complex series of formulas are concluded by an if statement, and if the if statement is true, then all the conditional formatting kicked in. So once you start getting to get acclimated to using these items, you will find that you can do a lot more powerful things, a lot more detailed analysis, a lot more cool stuff in Excel. So this is one of the things that I think is very worthwhile learning and exploring to figure out what the boundaries are of it. So we're going to talk about a few different iterations of this today. And first one, we're just going to talk about a very basic if statement. And I'm assuming everybody knows what the if statement represents. The if statement formula is basically just setting a condition. And if a condition is met, you return one result. If a condition is not met, you return another result. Now, there's a few things that we need to talk about with the context of the if statement. What you're going to be looking for, and what you're going to be input or outputting are going to be defined by the type of characters. And so this can actually vary. Generally speaking, if you're looking for a text input or output, then it needs to be specified by quotation marks. And if you're looking for a numeric input or output, then it does not need to be specified by quotation marks. The exception to that is if you're trying to actually check true or false statements, which do come up, but we're going to see them here in a second. You do not actually need to put quotation marks around true or false to actually check true or false statements, because those are actually just natural functions in Excel. But that being said, let's just go ahead and write a very basic if statement. You can kind of see here that I've got the names of the accounting professors up here, along with the accounting disciplines that they teach. Okay, and got myself in the AIS, Dr. Caden with tax, only tax, Dr. Caden. It's actually not true. She used to teach financial accounting too, but she doesn't want that part of her history exposed, you know. It's like going to be in the files of when she writes her biography. It's going to be one of those guilty sins that she has to disclose, that she actually taught real accounting at one point in her career, because you're going to hear me talk about it. Tax is not real accounting. We don't have debits on the left or credits on the right. No, come on now. Then Dr. Otero teaches managerial or cost, which she will tell you the distinction between cost and managerial. And she gets about 5 words in and I tune out. Okay, so they're the same, let's just be honest. And then Dr. Eisen teaches financial and financial disciplines. So what about we just go ahead and set up a very simple condition with the very first instructor, Dr. Barnes. So we're going to say equals if, and we're going to specify the discipline next to Dr. Barnes to AIS, and we're going to say equals AIS, then booyah, otherwise just boo. All right, so basically I have a condition. If that cell is equal to AIS, then it's a cheer. If it's not, it's a boo. All right. That's all there is to it. Pretty straightforward. Now, this does preclude the fact, so we can actually see that if I just delete AIS there, then there's a problem. And that's an if statement. Now, you're probably arguing, so didn't you say you also teach auditing, Dr. Barnes, and to be? Well, some days I do feel like booing when I teach auditing. It's a simple fact. But we'll actually deal with that here in a little bit, because there's a possibility of that happening where auditing comes up. So we want to make sure that we address that possibility. All right, let's go ahead and talk about some other statements that are related, and we're going to embed those statements here in just a second. But we've got and or statements. Now, one of the confusing things about old formatting for Excel, and this is not necessarily true for newer functions, all right? Make a note of this, that newer functions do not have to prescribe to this rule, but and or still do, is that in human language speaking, we would put and in the middle of a statement, okay? So I'd say Michael and Stacy, that would be a natural statement, or Michael or Stacy, that would be an English language statement. And I think that's pretty true for most grammatical series of any language. Excel cannot do that, cannot embed a function into the middle of a statement. We have to actually include the function at the beginning of the statement. Again, this is for most traditional formulas, ones that have existed in Excel for 20, 30 years. Now, we will look at some formulas that do not prescribe to that rule. We can't actually use the formulas in the middle of the function. But generally, when we start out a functional statement, we have to use the function at the beginning. So in order to use the and statement, we're going to say equals and, which is completely and totally not intuitive. But basically, we're saying if these all logical tests meet, then we're happy here. So let's just go ahead and say B3 equals tax. And then we're going to put a comma and we're going to put another logical statement in there. And we're going to say B5 equals financial. And you will notice that we can actually create more logical statements here. So if I wanted to create more logical statements, I can add on 2 is enough for now, because we're just going to look at these two statements. But if both those conditions are met, it's going to come back with a value of true. All right. Now, if I change any one of these conditions, that's going to be false. So it's looking for all of the items that are in the series of the statement to be correct. So that's an interesting counterpoint to the or statement. Now, the or statement is, you know how it works in English language, so it's going to work the same way, except we're going to start it out at the very beginning. So let's go to the cell below or, and we're going to type in equals or, and we're just going to type in the same formula as above. We're going to say B3 equals tax, and B5 equals financial. Oh, I'm going to have to actually put an equal sign for that to work. So same statement, the same results, but you'll notice that if I delete one of these, it's not going to change the statements. It's going to change the and statement, but will not change the or statement, because it's only looking for at least one of those conditions to be met. I have to actually change both statements for that statement to be false. This also leads to an interesting implication. We don't necessarily have to specify separate cells for or statements. We can specify the same cell, but different conditions. So let's go ahead and go to the cell right below. We're going to say equals or. We go to B2 equals AIS. And then we're also going to do B2 again. gonna say auditing. Because as we know, I teach both classes. So it's gotta be one of those two classes. So I've got AIS here, if I change this to auditing. Stays true. If I delete it, it goes false. The other statements are simple enough, but again, the real power in these statements are not the functions by themselves. It's when we can actually pair the functions together to create something a little bit that's common between the two. So we know the and or statements are just going to return true or false, whereas if will actually return a statement based on a condition. So what if we set the condition to and or? We can actually do something a little bit more complex, a little bit more interesting. All right, so let's just go ahead and do an if and statement. That's just going to be equals if. And then before we do anything else, we're going to set our condition of the logical test as an and formula. And same thing as before, we're going to say B3 equals tax. And also B5 equals financial. All right, so that's our conditions. We're saying, all right, and B3 has to equal tax and B5 has to equal financial. If both those conditions are met, because we're setting up a dual condition with the and statement, then we could set a response. So we'll say yes with an exclamation point. And then if it's not met, we'll say no. Darth Vader type no. In honor of James Earl. May he rest in peace. All right. So now we have an and statement embedded with an if statement, where if I change one thing, no. Then we can do the same thing with an or statement. Okay, we can say the same thing, set a condition with an or statement. So let's just go ahead and do an if or statement equals if or. And we're gonna have a little bit of fun with Dr. Otero. Okay. So we're gonna say B4 equals managerial. We're also gonna say B4 is our second option equals cost. So our condition is it has to be either managerial or cost, one of those two. Because again, she teaches one, again, same thing, but they're just different words, all right? So let's just go ahead and say, what is our result of return if we meet that? We'll say happy. And we'll put a smiley face in here. If it's not met, we're gonna say grumpy with a frowny face. By the way, if you ever get Dr. Bertera in a grumpy mood, run for the hills. Run for the hills. All right, so it's managerial. Dr. Otero's happy. Change it to cost. She's still happy. But because I'm devious, I'm going to change it to auditing. Now she's grumpy. And that's an actual statement. She would get very grumpy if she was forced to teach auditing. Very grumpy. She said so as much. Said as much that would be the case. All right, we'll come back to if statements here in just a second, because I think that there's one more if statement I want to talk about, which I think is the one that I use the most and really, really important to know how to do. But let's go ahead and talk about some other functions here. I'm going to talk about count and then a basic sum if function. So the count functions are all fairly similar, but they have different criteria based on what item you're using. So we can see here some grades from my students that I have listed up. And it looks like Michael Barnes just didn't do the assignment because that's the way he rolls. And then Stacy Caden tried to do the assignment, but her dog ate it. Which actually, if you know Dr. Caden's dog, is probably not all that surprising. Okay, the dog is very poorly behaved. Everybody else did the assignment, so let's just go ahead and we're going to count. And all I want to do is I want to count these inputs here, D2 through D7. And we get a result of 4. Now, this is an important note. The reason we get a result of 4, we've actually got 5 results, but one of these is not a numeric input. It is a alpha input. Count will only count, the count function itself, the count function by itself will only count numeric inputs. This is kind of illustration of that. Now hold on to that because we're going to come on to another formula here that's really, really important to note. All right. Let's go ahead and now pair this with if statements. So we're going to talk about another version of if, which is kind of specialized. So count if. And for this one, it's a little bit weird because we don't set up the criteria statement. We set up the range first. And then we set up the criteria. So the criteria are set. I remember, I think this one's really special. I said just say type in 10, I don't think it'll work. Actually, no, it does work. Okay, my apologies. So, yeah, so count if I type in a number 10, I guess it does count that. I'm just curious now because I know that you have to get a little bit dicey with some of the formulas here. So I'm going to try equals count if. This is just my own personal curiosity. We're doing a non-equality. So if I don't do that, so if I say greater than 8, should come back 4. Let's see what happens. Okay, so I think that's where you actually have to set up the formula. There we go. Okay. That's just actually the formula set up right here. So just for context. There's a couple of ways that you can set this up. And this one I did a non-equality. And the reason I was asking because I was curious on the previous formula. If I have typed in 10, or in past I've typed in equals 10, I think you just get the same result. So, which I never really thought about it before, but that's kind of interesting. All right, so, and count if can be set, as you can kind of see, count if can be set for a numeric condition. It can also be set for a non-numeric condition. Like say, for example, I wanted to count if, oops, count. That's what I'm sure what happens when I try to type and talk at the same time. Now I've got count if. Come on now. I want to set condition to like a name. It will actually count a name. So it doesn't require a quantitative input for this particular one. Count blank should be pretty obvious. Going to count the number of blanks. So count blank, we're just going to specify that same range, which are going to be our scores. And we got one blank up there, which we can verify is the case. Now, remember I said for counts, the count formula only counts numeric inputs. But what if we wanted to count any input, whether it was numeric or alpha? That's where we would use the count A formula. The count A formula will actually count anything that's input, which can be a really important distinction. Remember, sometimes that we will have fields that look numeric, but actually have alpha information. So if we're trying to count information that is not necessarily numeric, we want to use the count A to count, make sure we count anything at all that's input there. Then finally, we have the sum if fields. Now, I'm assuming that you all know the sum if formula. Just kind of a refresher. The sum if formula can expand out to conditional analysis across multiple ranges. So we can actually use multiple criteria with sum ifs or count ifs. We're going to keep it pretty simple for right now, simply because, again, we're starting out. We may get into a little bit more depth on those formulas, but the sum if formula is basically just setting a condition, but then adding the sum. So let's do a single condition sum if. So sum if, and we're going to specify the range. We're going to set the criteria. I'm just going to do as I want to do equals 10. Again, I think if you just type in 10, it would be fine. We have 3 numbers that are 10 and it sums those together. Now, something I want to point out sum ifs is that you may have noticed when I was typing in the formula that it's looking for a logical, sorry, I should type in the right formula, sum if. It's looking for a range, but then it also looks for something called the sum range, and that's an optional input. What if I wanted to set a criteria in one series or one array, and then add the items that are in an array, a separate array? So say, for example, I'm going to look at a range right here. I'm going to say this range of last names, B2 through B7. And I'm going to set my criteria as Deers. And then I can do an alternate sum range, which is going to be the corresponding cell in the array across from it will sum all those items. So we only get 10 right there, but what if I change Otero to Deers right here? Well, then it goes up to 20. So that's kind of a useful tool for being able to match information across arrays. All right, last function we're going to talk about, or I guess is the last function because this is a series of formulas, is going to be the nested if function. This is a really, really powerful one. It's one that I use very frequently. So as you will notice here, I've got percentage grades for the course, and if I wanted to assign a letter grade, there's pretty straightforward criteria that I can do for that, and I can just type it in for 6 students without too much problem. But what if I want to do it for multiple students, more students than that, like say 25, which is the number of students in this course? It's probably still not all that hard to do for 25 students. What if I want to do it for all my students across all my courses? So that's a little bit more on the range of 60. Now we're getting into a lot more work. I once taught a class with 140 students in it. That was a lot of work to try to do something like that, not something I want to type out by hand. So in that case, if I want to assign something that's pretty straightforward, but do it consistently, I can use what I call a nested if function to do so. So this one's kind of predicated on the idea that you understand how the sequence of if formulas work. Now, I want to clarify that there are multiple ways to go about this particular task. You may have a preference that you prefer to this, and that's fine. If you do not like this, you don't ever have to use this in reality. There's multiple ways to approach this particular problem. This is one that I've used for a long time, and I think it's valuable to know, not necessarily because you're going to use it in an application that's about to show you, but because to understand how if formulas interact with each other when we actually use multiple of them in the same formula, okay, or same function, I should say. Function, I'm using those words wrong. So formula is the actual equation. The function is the items that are used in the equation. I've talked about nested if function, which is not true. It's actually a formula. So let's go ahead and try it. So what I'm going to do is I want to actually have a formula that assigns a letter grade based on what the performance is right over here. So the very first thing I'm going to do is an equal if statement. And I'm going to say if this cell right here, F2, and then we'll say greater than 0.8949, we'll say that. Because I'm pretty nice, so if it's pretty close to rounding up, if it would round up, then I will go ahead and give that. So we'll say greater than 0.8949. We're going to say A. And then it's going to say, well, what's your alternate condition? The problem is I've got 4 more other alternate conditions. Okay, so I can't just close it right here and say everybody else gets an F. That would, well, you want to talk about bad evaluations then, yeah. All right, we can't quite do that. So what we're going to do is we're going to add another if statement. We're going to go back to that same cell, and we're going to say F2 is greater than 0.7949. I'm going to give the value of B. Now, this is an important distinction to make because I basically said in my first condition that if the formula, or if the cell that I'm looking at is greater than 0.8949, if it's an A, it will assign it an A. Then I'm going to the next step and saying, well, if it's greater than this amount, it's a B. You may say, well, this one down here is an A, Dr. Barnes, but you've assigned it a condition of a B. The reason that we write this in the sequence that we do is that it's going to be assigned an A first if at all possible. If it's not possible to assign it an A, it will go to the next condition and try to see if it meets that condition. And that's why we have to write the sequence the way that we do. We have to write in a specific sequence that will identify it because these are ordinals. So next is we're going to do C. F2 is greater than 0.6949. Then C. Then if F2 greater than 0.5949. Then D. And this is a personal preference item right here. When I usually write this out, usually I will write out an equation for F. But That's mostly because if I have an incorrect input in my cells, I want to make sure that it comes out as not coming up as an F or something else. But with a small number of students, it usually is not going to matter that much. So we can just set our final condition as F. And then we've got to set a whole bunch of parentheses to close everything. So what this is saying is, let's look. Is it an A? If it's yes, we put an A in. If the answer is no, we'll move on to the next argument. Is it a B? If the answer is yes, we'll put a B in. If the answer is no, we'll move on to the next argument. And we'll keep doing that for A, B, C, and D. If it doesn't meet any of those conditions, it will assign an F. So then we can put that in there. And sure enough, that Dr. Barnes fellow got a C. Which, that's good enough to pass the CPA exam, so that's all I'm saying. Okay. And then we can just flash fill all those out. Now, again, there's multiple ways to approach this particular paradox. I don't think that this is a one-size-fits-all solution. I do think it's important to understand how if statements work, especially sequential series of functions within an if statement, because you can stack those on top of each other to create something pretty powerful, which is why we went through the rigmarole of this particular task. All right, and that does it for Excel Friday today. We've got some homework to talk about, though. Hopefully you didn't find this homework too challenging. I think this was actually a step down from chapters 2 and chapters 3, but it will still be relevant to the exam, so let's go ahead and talk about it. So question number 2 is the first one. Advantages of relational data models generally include what? So what do you guys think? Is reduced information redundancy, is that an advantage? Yeah, that's one of the very first advantages we talked about. Because remember, conventional systems, they had to put information in every single time it was used in a process or a report. In a relational data model, we put it in usually one time or a minimum number of times, especially if it's a key, so that we can actually reduce that redundancy, and that way we don't have to store it multiple times. It is definitely not low cost. It's going to be higher cost simply because of this more complex mechanism. Ease of implementation, we talked about that, especially if we're talking about trying to fix conventional systems. It is a costly process to go through because older systems were not set up to match relational data model setups, okay? We have to not only transition all the information, but transition the setups as well. And the efficiency, it can be a problem with efficiency because you can't just go print report. You have to set up the reports, set up the queries automatically. The good news is it can be efficient once you already have the queries created. A lot of systems already do that. They have standard queries that will run on the system themselves. We will see that when we actually look at NetSuite in a little bit more depth. All right, a class in a relational database model is defined as what? Okay, so what are our general 3 categories for classes that we've defined? Okay, we've said these are going to be our classes in our UML diagrams, and these are kind of what we utilize to set up a relational database model. What are those called? REA. Resources, events, and agents. Good, okay. We also have a 4th one that kind of falls outside of it. It's an informational item. What was that called? Conceptual structure? Yeah, conceptual structure, okay. So we're looking for something that loosely defines those, all right? So a class and relational database model is a symbol whole, no. Characteristics of property table, now that's going to be an attribute, okay? That's what they're talking about there. Person, place, thing, or transaction or event about which information is stored. Thing seems like I got a winner right there. That kind of captures all of those items that we talked about. Person, place, thing, transaction, or event. So that matches our resource, events, and agents or conceptual structures. Being or existence, especially considered distinct and independent, self-contained. That actually sounds like it would be an answer to like a philosophy course. Okay, yeah. So even though I've got a doctorate in philosophy, I don't teach philosophy here. You know, at least not directly. All right, number 12. Which of the following is a valid primary key for a cash receipt table? All right, I know that we've talked about this in multiple situations already, but it's really important to understand the distinction, okay? Primary key is a unique identifier. This is what field will we use as a unique identifier for this particular table? This should be pretty straightforward. It's, you're going to check mark it and say, the answer to this is not the issue that we should make sure we understand. We should make sure we understand specifically what do we mean by primary key. Okay, so we want a unique identifier that, and when we say unique, it can't be repetitive, and every single transaction has to have one. So what do you guys think? Purchase order number? Purchase order number doesn't really make any sense. First of all, that would be something that would come from a customer, and secondly, it doesn't really relate to cash receipts. Check number. Now, this is an important one, okay? I want you to remember this. What is the check number? Is the check number coming from our system, or is it coming from the customer system? Customers, probably the customer's bank, okay? The customer, the bank issues a series of check numbers. So there's not going to be a sequential mechanism. There's not going to be a unique identifier. You could have customers that are the exact same check numbers. I just opened my account. It's check number 1. Well, so did 3 other people that just sent you a check. Okay. So check number cannot be the case. Cash receipt number. That's definitely an item that's in our system. So that would be a good primary key. The receipt amount, we can have items for the same amount. So that would definitely not be a good primary key. So that's the only one that really makes any sense right here is cash receipt number. All right. Question number 16. Which of the following is a correct statement about primary keys? All right. So this is pretty obvious based on our previous discussion. The very first statement says the data values of a primary key must be different or unique. And we know that that's the case. That's one of the rules for primary keys. They have to be different. They have to be unique with one another. Primary is always another table's foreign key. That's not a correct statement. A foreign key will be a primary key in another table, but that doesn't mean that a primary key has to be a foreign key in another table. In fact, if we're looking at primary keys that do not have a one-to-one relationship, we often cannot use them as foreign keys. A primary cannot be used in another table as a foreign key. Well, we can use it, just not always will. Most tables in a database may not require primary keys. All right. Most tables in a database will require primary keys. The only ones that don't are going to be the ones that are created as joins, like the ones that we looked at for an example on Monday, that are combinations of tables that do not have a one-to-one relationship primary keys. That was the example we looked on Monday. We talked a little bit about in detail. All right, which of the following is a correct statement about foreign keys? Okay, all foreign keys cannot be blank or null. Is that a correct statement? No, we can actually absolutely have foreign keys that are blank. All right, we can absolutely have foreign keys that are blank. Remember the example we talked about? That was the referential integrity rule. We said it was really confusing because they have to actually have a valid ID or they have to be null. And we said, why is that null? Well, say for example, you've got a place or place an order. What was my Jimmy John's? That was my example. So Jimmy John's is going to have orders for people who order through the app or order online, but somebody can walk in the store and order as well. Okay. We'll say, well, do they have a customer ID? Well, that's a question. Do you get asked for a customer ID when you buy a sandwich at Jimmy John's? No. Okay. That's a foreign key, but that's not necessarily, it means that it has to have a foreign key for a transaction to take place. So that's probably just going to be left blank because they say we didn't bother to ask. It was a cash or a credit card transaction in the store. So that's the example of where we can have a null key. So most foreign keys should not have any data values. There'd probably be a defeat the purpose of having a foreign key if it didn't have data values. A foreign key must be another table's primary key. That is a correct statement. Okay. Foreign key will be a primary key from another table. And remember, we find a one-to-one relationship with those foreign keys. So when we're talking about primary key used as a foreign key, it has to have a one-to-one relationship with the table it's being used in. An attribute cannot be a foreign key used in different tables. Absolutely can be. That's the whole point of it having a foreign key. All right, we just talked about the referential integrity rule. What is that? So referential integrity rule refers to foreign keys. It was a rule about foreign keys. And so referential integrity rule says that it has to be either a primary key value or it has to be null. One of those two. The only answer that makes sense in that context is going to be the foreign keys could be null. Doesn't mean they always are null. It just means that they can be under certain circumstances. Which of the following statements is correct about the entity integrity rule? So the entity integrity rule relates to primary keys, okay? Recites the conditions. Remember, primary keys have to be unique identifiers. That's what the entity integrity rule tells us. If that's the case, the rule requires each record's primary key cannot be blank or null. That's the entity integrity rule in a nutshell. So the entity integrity rule is an allusion back to the fact that it has to be a unique identifier, but the entity integrity rule actually specifically states that the primary key cannot be blank or null, which makes sense because if we know that the primary keys have to be unique identifiers, being blank kind of defeats that purpose. That means that we got a whole bunch that are going to be the same item. All right, 22. Which of the following is a best primary key for a cash disbursement table? All right. So again, we're talking about primary key, unique identifier. What would be the most likely to be a unique identifier for this table? Probably the disbursement voucher number. Everybody on board with that? Yes. All the other ones, they could be identifiers, but probably not for this table. They could be unique identifiers for other tables. What do you think about a purchase order, a check number? These again are customer generated items, so they could be unique identifiers, but it'll be for different entities. 23, which of the following could be an event in REA data models? So remember, REA data models, the UML diagrams that we're talking about, the event is basically what starts the transaction. All right. Examples of event: sale, Purchase, cash receipt, cash disbursement. Those are all items that kind of trigger accounting transactions. So which of these would be a good event in there? Can we kind of say sales falls with that since that's one of the ones I mentioned? Hope so. Okay. Just context. What is cash in REA data model? It's a resource. Good. Okay. What about customer? Agent. Yes, customer is an agent, and then inventory, another resource. Good. Okay. Which of the following could be a relationship table, i.e. to link two tables, all right? And this one's pretty much straightforward. Remember, we have an item that links two tables. The reason that we link tables is because for whatever reason, we cannot set up a series of foreign keys in either of the tables. That was the example in the author in the book scenario. We had authors who had written more than one book, and books had more than one author. There was no way to create a foreign key across those two tables because they had a one-to-many relationship or one-to-many multiplicities. So why do we set up these tables? Why do we set up these relationship tables? It's to actually link these two tables somehow. The easy way to do that is basically to say you take part of one table, part of another table, merge them together. So you've got tables that have got components of each, which means our answer is probably going to be something that alludes to two different tables, such as purchase line item table. Okay, purchase line item table, because we're going to be looking at line items for the purchases and the items that are going to be related to the customers who have those purchases. So I'm assuming it could be actually, if it was purchase line item table, we're probably talking about inventory items because that makes more sense because you only have one customer for a purchase, but you actually can have multiple line items in the inventory. So purchase line item table would contain all of those. Which of the following is not a valid link between tables? This one's pretty straightforward. We're looking for tables that have relationships to one another, obvious implicit relationships to one another. Are inventory involved in sales? What do you guys think? Do you think most companies sell inventory? Just not a trick question. Not a trick question. Just making you think. Yes. Okay. So sales and inventory tables probably have a good link. Purchases and cash disbursements. Okay. If you make a purchase, do you eventually have to disperse cash to whoever you bought something from? Probably so. So that makes sense as a link table. Salesperson with customers. Do salespeople interact with customers? Like when you walk into a electronics store, you have like about 5 of them that come and can help you with anything, and they're just doing their job. But it's kind of nice. Sometimes you just want to browse, but the salespeople are definitely linked to the customers. Vendor to customers. Do most vendors interact with customers? Unless your company name is Amazon, the answer is no. Okay, your company name is Amazon. Amazon just says, "Hey, vendor, somebody bought something from us. Send it out to them now." Okay, which is not. It's kind of a shady way to do business. But for traditional businesses, yes, vendors and customers generally don't interact. So D is our answer. All right. So as you look some tables here, problems 15 and 16. So a cash receipt table below contains 7 attributes. Which of these could possibly be foreign keys? So this one's not as obvious as you might think, but we're going to talk through each of these 7 items. So we're going to say, could this be a foreign key? All right. So cash receipt table, we've got, first of all, the remittance advice attribute. Okay, remittance advice attribute. What do you guys think? Is this a foreign key? Now, the question is, could this be a foreign key in the cash receipt table? I guess I should specify. You may say, look, it's a primary key. It absolutely could be a foreign key in another table, Dr. Barnes. You say, that would be a correct statement, okay? So if you said, yes, this could be a foreign key in a different table, that's an accurate statement. Let's get back to this table. Is it a foreign key in this table? No, what is it in this table? It's a primary key, okay? It's a primary key. So if you answered yes, it could be a foreign key, you're technically correct. If you watch Futurama, that's the best kind of correct, all right? But for this table, it's not a foreign key. Date, could date be a foreign key? Date could not be a foreign key, not in this table or another table. So we could actually throw that out. Amount, is amount a foreign key? No. Remember, foreign key is going to be a primary key from another table that represents a unique identifier from that table. Could you have the same date or the same amount in certain transactions? Absolutely. Happens all the time. Customer number. What do you guys think? Would that be a good foreign key? Yes, it sounds like a customer that comes from the customer ID table or customer table, and it's something that we can link over pretty easily here. So that's a good foreign key. Check number. Is that a good foreign key? This is where the sirens should go on. Danger, danger. Dr. Barnes is trying to trick you. I absolutely am trying to trick you here. So it's like, yeah, it sounds like a good foreign. What's the problem with this being a foreign key? So foreign key has to be a primary key from another table which primary key by definition is a unique identifier. Who assigns check numbers? Is it our entity? No, it's usually the bank of the customer. So is it possible that we could have the same check number that repeats? Absolutely. That means that it can't be a foreign key because it's not a primary key. Okay. So check number cannot be a foreign key. All right, let's do these last two together. Invoice number and cashier number. Do you guys think these could be foreign keys? Absolutely. Come from invoice table and then cash disbursements table, or cashier table, I guess I should say. So we've got customer number, invoice number, cashier number. Those all can be foreign keys, and then our primary key is remittance advice. All right, let's go a little bit more in depth. Okay. So a sales invoice typically includes the date of sale, salesperson, customer data, items included in the sale, and amount. Which foreign key should be added to the following table? So this table down here to link all of these data elements. All right. So basically what we're going to be doing here is we're adding foreign keys. Now this seems really, really easy, but we need to stop and think about this because it's not as apparent as you might think. And this has to do with a lot what we've talked about the past 2 weeks. So let's just go ahead and I'm going to give you some items and I want you to tell me, could they be valid foreign keys here? All right. First one should be easy. Could I put salesperson, because we got actually here, salesperson is one of those items here. Could I have salesperson as a foreign key? Absolutely. We're assuming that one sale is going to be one salesperson, so we could actually include from the salesperson's table, whoever the salesperson responsible for this particular transaction. So yeah, good foreign key. We're off to a rolling start, all right? Then we have customer data. Could I put customer number as a foreign key? Yeah, again, assumption, one customer for sale, okay? So we can actually include that as a foreign key in this particular table. I think that we've got 2 foreign keys pretty easily identified. All right, next we've got items included in the sale. What do we call items that we sell? Most businesses sell. You can say services. And I say, yeah, but we're talking about a merchandising manufacturing firm. That's called inventory. So inventory ID, could that be a foreign key? All right, now I asked this question really cruelly. I shouldn't have asked it that way. Could it be a foreign key? It could be under one very specific condition. What does that condition have to be? This is important to understand, by the way. So if you don't know the condition, you better perk up your ears and say, okay, Dr. Barnes has asked me to pay attention. I should be writing this down, okay?
Items in one sale.
Yes, if there's multiple items in one sale, we cannot use it as a foreign key because it's not a unique identifier, all right? So remember, our condition says for our tables that we cannot have multiple items in the same field. So the only way we could use inventory ID as a foreign key here is if every sale had to have one inventory item and only one inventory item. Remember the previous 2, I said salesperson ID, that has to be one salesperson for per transaction per sale. I said customer has to be one customer per sale. This would have to be one inventory item per sale. Because if we had multiple inventory items in the sale, what would that cell look like? It would have multiple inventory IDs, which doesn't work. That's one of our rules. We can't put multiple inputs into the same cell. Okay. That's why we have that sales line item table, so that we can actually have multiple occurrences of a sale, but you can see what each of the inventory items are. So in most circumstances, the situation is going to be no, we would not be able to include inventory as a foreign key. The only scenario we could is if every sale has exactly one inventory item, which most organizations don't follow that protocol. So again, I want you to think about this and think about the rationale behind it. All right. If you don't understand the rationale behind it, get to understand it because this is really important to remember. Okay. So everybody follow the logic here? Okay. All right. Along those same lines, okay, well, we got amount, okay. Is amount a foreign key? What about date? No, but amount and date are not foreign keys. All right. So let's go ahead and a little bit further, something that's not listed up here. They're eventually going to have to make a disbursement back to us. They're gonna have to pay for their sale. So we're gonna have a cash receipt, correct? Okay. So let's say that we have some sort of unique identifier for the receipt, like the receipt number or the remittance number, something along those lines. Could that be a foreign key associated with the sale? Now everybody's really afraid to answer. It's like, it depends. Remember, the answer to this course is if you don't know, it depends. It's always a valid answer, okay? And it's true. In this situation, it does depend, okay? What do we say the criteria was for inventory to be recognized as a foreign key? Has to be one inventory and only one inventory item. Same is true held for remittance, okay? If the customer is required to pay the entire balance in one payment, then we could actually say the remittance would be a valid foreign key here. Is it possible a customer could make payments in installments? Have you ever thought about that? Like, I know most of you are gonna go out and buy a car and just like, yeah, 30 grand, here you go. Yeah. No, that doesn't work, unfortunately, in most situations. There are scenarios where we could say, all right, we have to make the payment in multiple instances. If we have a scenario where a business operates where the customer makes multiple payments for a one transaction, remittance advice would not work because we would have multiple records, multiple remittances, and we can't include multiple remittances there. So again, the core goal here is to say, could it be included as a foreign key? Answer is yes. But you have to give me the understanding of what condition has to exist for it to be a foreign key. And the answer is one remittance only for a sales transaction. Otherwise, we can't include it as a foreign key. All right, we're done. We will start chapter 5. Yeah, chapter 5, we're gonna start business processes on Monday. See you all then. Have a good weekend.